Let f of x equal 4x minus 1. I'm going to use the epsilon delta definition. Plug this in. To prove it, limit of f of x as x approaches 3 equals 11. First of all, you think it might be true. X gets really close to 3. Is 4 times x minus 1 going to be really close to 11? Well, since 4 times 3 minus 1 actually equals 11, yeah, you figure it's going to be pretty close. This is a well-behaved function. So what we need eventually is this. We need, as our final punchline at the end, to be able to say, aha, absolute value of f of x minus 11, sure enough, is less than epsilon. When we conclude that, we'll be done. So that means that the absolute value of 4x minus 1 minus 11 will have been shown to be less than epsilon. Okay, let's work on that expression. See, we've got control, since x is approaching 5, we've got control over the absolute value of x minus 3. If we can express this in terms of the absolute value of x minus 3, then we'll have something that we can kind of work with. So we'll keep working on it. Simplify absolute value of 4x minus 12. We need that to be less than epsilon, but I think we can get there. Because 4 is positive, when we factor out the 4, we can bring the 4 out of the absolute value bars and write 4 times the absolute value of x minus 3 is less than epsilon. So if we can get there, I think we can find our way to the end. So if we need that expression to be less than epsilon, what kind of requirement should we then place on this expression? It needs to be less than what? Epsilon divided by 4, yeah. This needs to be less than epsilon divided by 4. So that's our delta. That's our delta. Delta equals epsilon over 4. This can be considered just kind of scratch work. This is really not part of the proof, but it's finding a delta that works. That's going to work for an arbitrary epsilon. So we want to show that the delta that we found actually works. So imagine someone hands us an arbitrary epsilon greater than 0. They're not going to tell us what it is. They're just going to give us epsilon greater than 0. And let delta equal epsilon over 4. Let delta equal epsilon over 4. And suppose that x is actually within delta units of 3. Absolute value of x minus 3 is less than delta. How to show this? Well, I like to start with the expression, the absolute value of f of x minus 11. And if I can write an equal sign, an equal sign, an equal sign, eventually a less than symbol, and conclude with an epsilon at the end, then we can string them all together, and we can conclude that the absolute value of f of x minus 11 is less than epsilon. So here goes. This equals the absolute value of, 4x minus 1 minus 11. And if I had more space, I would work my way down the page. In fact, I don't feel really all that good about this, so I'm going to put it up there. This equals the absolute value of 4x minus 12. This equals 4 times the absolute value of x minus 3. I know, been there, done that. But we did all that, so this would work. Now, here's the key step. And I think this is probably the most challenging step in the process. We come back here and look and see what we're supposing. We're supposing that the absolute value of x minus 3 is less than delta. Well, if we're supposing that, then 4 times the absolute value of x minus 3 is less than what?
4 delta.
4 delta. So this is less than 4 delta. But what's delta? Epsilon over 4. So this equals 4 times epsilon over 4, which equals epsilon. So this expression is equal to this, which is equal to this, which is equal to this, which is less than this, which is equal to this, which equals epsilon. So string them all together, and the absolute value of f of x minus 11 is less than epsilon. So that concludes it. And that's probably a good place to conclude the first day of class.